All right, so let's do some georeferencing. As I mentioned earlier, this is our Codorus State Park map, and we're going to georeference it and putting it into the right place in space. So one of the first things I'm going to do here is I'm going to zoom to the full extent of this map. Again, there's our ArcGIS Online map. And following my rules of thumb, my very first rule of thumb is to place some reference data in my data frame that my data frame is going to accept its coordinate system. That's already done. One of the other ones is to make sure that auto adjust is turned off. Okay, so that's turned off. My other rule of thumb, green means go, red means stop, so I have to remember that. And then the last one, of course, is going to be to work in a clockwise fashion from the upper left. So those two we'll see kind of come into play here. So if I zoom back into my known area, just south of Harrisburg, just over the Maryland line, there's Lake Marburg and Codorus State Park. Now, one of the things that I can use, instead of creating these links that are going to be point locations on the map way out in the Atlantic and then bringing them all the way over here, I can actually use fit to display, which is one of the tools that I talked about in the earlier one of the earlier videos, that is going to basically take that raster and boom, bring it right into the general area of where I'm trying to georeference it. So what I'm going to do is I'm going to back out of this just a little bit, and you can see we're sort of horizontally oriented here, but if I turn off the Codorus JPEG in the real world, Codorus State Park sort of sits kind of at a 45-degree angle here with Lake Marburg. So what I'm going to do is I'm going to turn on that Codorus JPEG, and I'm going to do some rough georeferencing here by using these tools. And so I'll use the rotate tool, and I'll click it and just kind of turn it into the general direction that Lake Marburg is oriented. And I'm going to use the shift tool to kind of bring it down and away so I can kind of see both. And I can see I really have to kind of make this map a little bit smaller. So I'm going to use my pan tool to sort of bring everything into view here. And then I'm going to use the scale tool. This can be a little bit of a temperamental tool, but what I usually do is I just start out with it early on and then I don't use it again throughout the rest of the process. So I'll just click and hold and just kind of size this down just a little bit. I'm kind of moving in a diagonal motion, and now I'm much closer to the size that Lake Marburg is relative to Lake Marburg out here in the reference data, and I feel like that's pretty close for now. I could actually take this and shift it over top of where the actual lake is, but I do get this covered up. I do cover up the reference data underneath. I can set up a transparency. I can come over here and use my effects tool, which you guys are more than welcome to use as well. And I can set up a transparency on the Codorus JPEG. And again, there's the different target layers. In this case, you can set up transparency on the streets and on the imagery layers, but in this case I want to set up a transparency on the JPEG itself, and I'll just use this slider to adjust that. And now we can actually see that we can see the reference data underneath of the actual map. I might want to take that and make it a little bit more transparent. And now we can see the two together. For the purposes of this, though, I really like to take mine and keep a full transparency, and we'll use that effects tool maybe a little bit later when I show you how close my georeference came. But I'm going to go ahead and just zoom to previous here, and I'm going to take my shift tool and kind of bring that raster back over here, because now I can see my road intersections, which is what I'm going to use as my control points on this map to move this raster to tighten it up where it should go here in the registered data. We mentioned the different transformation methods within the lecture. You can see all the different ones here. I haven't set any control points, so none of these are available. But if we were to go into the help, as I mentioned in the overview document, I'm going to let that launch, and I'm going to search on georeferencing, and I've already done that earlier, so that does pop up. And it gives you several different options here. What I want you to do, as I mentioned in the slides, is to go to Fundamentals for Georeferencing a Raster Dataset. And this reading is going to be really critical to you understanding this, not only this demo, but also the overall process. So you guys can read through that, but I did want to point out a couple of things. This is what I mean by transforming the raster and the icky math. We're going from image space, which is basically the raster sort of floating out there in the Atlantic Ocean, and we're telling that raster you need to be in this coordinate space. And I'm using my ArcGIS Online data for my reference to tell it where it needs to go. And so these are all the different calculations that it does. And of course, if we scroll down a little bit further, it starts to talk about the difference between the different transformations. This paragraph in particular really goes over the three different types of major transformations, the first order, second order, and third order polynomial. For what we're doing for this particular demo, and probably for project number 1, a first, maybe a second order polynomial would be required. Usually first order is all you need. So if you're using a first order polynomial, this statement right here is very key, that if you're just scaling or stretching or rotating, then basically you can use a first order polynomial transformation to adjust your raster to your reference data. If it's got to be bent or curved or switched around or stretched a little bit more, you would want to go into a second or third order polynomial. And then it goes on and talks about the adjust and the spline transformations, the spline right here, and then of course the adjust transformation, used more for local type maps, which I could probably use for the Codorus map, but it seems that it's scalable to the reference data, so I'm just going to stick with the first or maybe a second order polynomial. And then interpreting the root mean square error. Again, this is a little more in-depth discussion of what that error means. Again, it's a statistical calculation of how close you're actually getting your interpolated or digitized points to the actual location in the real world. That calculation is going to be really key when you start to look at how tightly your raster is fitting. So again, referring to this, you want to give this a good read. This is one that I use as a resource all the time, both when I do this demonstration but also when I do georeferencing on my own. So this is a definite good read within the help menu for ArcGIS. So again, the fundamentals for georeferencing a raster data set. I'm going to go ahead and close that out, and I'm just going to kind of get on with it and actually georeference this raster. So I'm looking for known locations on this raster and known locations in the real world here, or this registered data set, if you will. So I'm going to go ahead and zoom in to this corner right here. And again, this is not a high quality raster. It's kind of tough to read the names of the roads, so I'm really going to rely on the shapes of the roads, or the way the lines of the roads are kind of laid out in the real world, and try to find those same patterns over in my registered data. So I'm going to go ahead and grab my add control points tool here, and you can get as tight in as you want, and I recommend if you want a good georeference, go ahead and tighten up on it. So just give that a second to refresh, and there's my intersection. We can see the quality really drops off here. It's very pixelated, but I know that this is the intersection of these two roads, so I'm going to say we're right about there. Green means go, so that cross is going to move to wherever I click next. Now the good thing about the georeferencing tool is that while it's looking for a place to go to, you can actually interact with the other tools and then bring that tool back in. So I'm going to zoom to previous here, and zoom to previous again, and I know that this intersection happens to be somewhere over here, so I'm going to grab the zoom tool, get in a little tight, and again looking for that same pattern. Here's that, you can read it a lot better in this. This is Bankert Road and this is Black Road, so I'm looking for that intersection right there. So I'm going to go ahead and zoom in tightly here, and you guys will get the idea once I click on that link tool. See how it kind of comes back in, and when I click here, it's going to have a red cross. So what I'm going to do is I'm going to zoom to layer on Codorus.jpg, and then I'm going to zoom out just a little bit more, and you can get the gist of what I'm doing here. I'm basically telling this raster I want this point to move to this location, and I'm going to do that with several of these points all the way around the map, and then put it into the right place in space. So I'm going to quickly do this, look for a couple of different locations that I know are going to match up. I know that this road coming in here and this road is going to be a good intersection, and so I'll let that refresh. Again, not a very high quality raster. So I've clicked, and now I'm looking for, I kind of always do that when I demonstrate this, that it's sort of looking, but that's me just kind of swirling the mouse around. And I'll zoom to previous here, and zoom to previous again. And I know that was close to the bridge. So here's that road sort of sweeping in, and then there's the intersection that I'm looking for. And so once that refreshes, I'll get my control point back out, and again, green means go, red means stop, so that's where the raster is going to wind up. And so now I might come over here and use this road intersection. I might not zoom in as far this time. Alright. Now I'm going to grab my zoom tool and just getting my bearings here. Probably looking for this intersection right in here. The dam, the corner of the dam could be There's the dam right there, and there's the dam right there. So I could use that as an intersection if I wanted to, the very edge of it. But I'm going to look for this particular pattern right here. These two intersections, this intersection here and this intersection, are ones that I use typically. So I'm just going to go ahead and zoom in a little tight, and I can find that road pattern in the reference data fairly easily as well. And then in the next demo, when we use the national parks, which I'll let you guys practice on, we'll use state boundaries, which will be a lot easier to use. And so there's that same pattern that we were talking about. So click there, and I'll go back. I'm getting there. I'll do about 5 or 6 of these. All right. Getting good at this. Not quite sure where I was there. There we go. That's what I was looking for. So I want to bring that over to here. Alright, so I'll zoom to previous, come out a little bit. You could also just use these zoom tools to pop out a little bit. But you can see kind of where we're going. Let's just zoom in a little tighter here. Maybe that's where I want to kind of get my overall picture. And if you wanted to, you could actually create a bookmark. I'll just call this overall and say OK. And now I've created a bookmark of that location. So if I come in here and I kind of get lost and I don't know where I am in my raster and where to click and what's going on, I can always come back up to my bookmarks and just click on overall, and it'll bring me to the overall view of what I'm doing. So that's a handy dandy little way to keep track of what you're doing. I'm going to come into, let's say, this intersection here near the campground. I kind of know what I'm looking for. Use that intersection there. I'll use my bookmark, come back to overall. And so here's the campground area. Looks like we're looking for this intersection right here. Let me just double check that because I'm already losing my way here. Which one of these am I doing? There's that pattern. This road here, this road here, this road here. So this upper right hand corner one. So I'll zoom to previous. Zoom to previous. Alright, so I'm looking for that one. Let me come back to my overall view here. And again, I'm going to zoom into this area. And that's the road intersection that I want there. So I'll click there. And then I'll go back to my overall. And I think I've got quite a bit. I think I'm going to do one more over here. And notice, again, back to my rules of thumb, work in a clockwise direction. Notice that I kind of stayed away from jumping all over the place. And I started up here, worked around, came back around. And again, when you can, because you might not have corners that you can register to down in the lower parts of the map. But my last one is going to be down here. And this should give me a pretty good georeference. So I'm going to come here and I'm going to go to that location. I use my overall again. That's a handy dandy little trick. I'm going to come down to this area here. And I know that that's going to be that intersection of Frog Hollow Road, and I believe that's going to be Black Rock Road. So I'm going to go ahead and just click my last point there. And so I'm going to zoom to my overall. And so we're basically taking this map and saying, we want you to move over there. So what I'm going to do is I'm going to open up my link table here. And you can see all of my links. I've done 7 links. And you can see what the different transformations that are available to me. Again, I'm just trying to scale this thing. So the first order polynomial, the affine, will probably do just fine. The second order polynomial, you have to have at least 6 control points. So in this case, I have 7. And so it's happy to warp this just a little bit more. I think you need at least 10 to do a third order polynomial. So we're just going to keep it on first order polynomial. And you can see the map jumped. Auto adjust, I can just turn that on if I want to, and then let that change automatically. You can see that my residual is kind of high here, and I've got a couple of them that are really high. I can just take that 7th one and maybe delete that, and maybe that's going to help my RMS come down a little bit. So I'm going to go ahead and say, okay, you see that it came down significantly, but the lower we get that number, the better. We want that well as close to 1 as possible. But again, just for demonstration purposes, I just want to get in here and kind of show you how closely we got this. This is not too bad. And one of the things I'm going to do is turn off the streets and turn on the imagery. And now we can have fun and use the swipe tool. So here's the effects tool that we were using, and I've got this swipe tool here. I'm going to go ahead and zoom to layer so I can see the entire map. And if I use this swipe tool, what it does is allows me to swipe away the target layer. So in this case, the Codorus map. So I'll just slide that back, and you can kind of see, hey, Professor Alvarez kind of did an okay job here. I would probably want to tighten this up if I really wanted to use this data for something. But I can also inspect it much closer and see how I did. Another thing I can do is use the transparency now and kind of take that and jack it up to about 60%. And then we can really see it. It did pretty well there. Some of the islands, that island actually looks pretty good, but I can still use my swipe tool and just kind of see, you know, that's not bad. You can see that my shoreline looks pretty good. I think my transparency is a little high there, so I'm going to kind of bring it down so I can see my map a little bit better. There we go. We can see, I think I lined it up pretty well. So let's just say, for argument's sake, I was really happy with this. What I would want to do is come over to georeferencing and say update georeferencing. Now before I do that, and this will be the last thing I want to show you in this particular demo video, is again, notice that there is only a Codorus.jpg in here. Alright, so as soon as I come over here and I say update georeferencing, it's going to lock that raster in place. I'm going to zoom to layer here. Whoops, I removed it. Do not remove. I want to zoom to layer. Bear with me, sorry. Notice that my control points all went away, and I'm going to take that transparency and bring it down on Codorus back down to 0 so you can see that a little bit better. And so there is my raster where it should be, and now I can actually digitize information that I might not have otherwise had on this raster. So and that's actually going to be in the next module where I show you guys how to actually create shapefiles and digitize off of these rasters and actually attribute your polygons as well. But the last thing within this particular demo is actually show you that Codorus.jgw was generated. So as long as this JPEG and this JGW file accompany one another, this raster will stay put. All right. If for some reason you lose that file and you only have this Codorus JPEG, then it is just, again, another raster that is sitting out in raster space. So that's going to be really key to your understanding of georeferencing. And again, it's going to be one of the first things, if not the first thing you do as part of project number 1. So I'm going to wrap up this demo and just do a quick demo using some vector data, georeferencing to some vector data with the National Parks map. And that's just going to be an example of how to georeference using local data, so you don't have to be at the mercy of something that is online like ArcGIS Online. So there's our Codorus State Park map placed in the right place in space.